Yesterday we completed about electrophiles and up to neutral electrophiles. Example BeCl2, BH3, ZnCl2, that one. And next, one more in that only the continuous point. Same, what is that? Neutral electrophiles. In that one only, the neutral electrophiles. Neutral electrophiles. It will get 2 minutes disturbance now. Neutral electrophiles is nothing but neutral covalent compounds. Here, neutral covalent compounds. Neutral covalent compounds in which central atom has complete or in which central atom has complete or expanded octet. Complete or expanded octet. Complete or expanded octet and has unfilled D subshell. Unfilled D subshell is a neutral electrophile. Is a neutral electrophile. That means the central atom has an octet role or else expanded octet role, and some it will have unfilled DRB D subshells. Such a type of compounds are called neutral electrophiles. And example here for neutral electrophiles: SnCl4, stannous chloride, and SiCl4, and PCl5, phosphorus pentachloride, SF6, sulfur hexafluoride, IF7, and CO2, and SO3. These are neutral electrophiles. And here the important note: electrophiles are Lewis acids. Electrophiles are Lewis acids. That means electron less density, electron deficient elements. Electrophiles are Lewis acids. Electrophile, that means electrophile attacks. Electrophile attacks at electron rich centers. At electron rich centers, that means more number of electrons. Electron rich centers. Electron rich centers of substance. Electrophiles are Lewis acids is nothing but electron deficiency elements. So electrophile attacks at the electron rich centers of the substance. That means more number of electrons. And next, after this, the second one, nucleophiles. With the heading nucleophiles. Opposite of electrophiles. Nucleophiles is nothing but electron rich species. Electron deficiency is electrophiles, and here nucleophile is electron rich species or electron donor. Electron rich species or electron donor or electron donor is nucleophile. Electron donor is nucleophile. And nucleophile can be classified into three types. One is the first one, charged nucleophile, like electrophile only, but opposite of electrophile. Charged nucleophile. Electrophile is nothing but positive, and nucleophile is nothing but negative. Charged nucleophile, negatively charged species. Then negatively charged species. Negatively charged species. Or charged nucleophiles. Or charged nucleophiles. Example here, charged nucleophile is nothing but negative only. Example, H minus hydride ion and hydroxide ion and RO minus and CH3 minus and X minus, etc. These are charged nucleophiles. And second one, neutral nucleophiles. Second one, neutral nucleophiles. Neutral nucleophiles. In neutral nucleophiles, neutral covalent compounds, neutral covalent compounds, neutral covalent compounds in which central atom has, in which central atom has in which central atom has complete octet, complete octet has at least one lone pair. It should have at least one lone pair. That means it should be complete octet electronic octet rule. It should follow the complete octet rule, and it should have at least one lone pair of electrons. Lone pair of electrons, and all atoms present in the central atom. Sorry, up to here only enough. Lone pair of electrons. Example, ammonia. Ammonia, NH3 and primary amines and secondary amines and tertiary amines and NH2 hydrogen, NH2, NH2. This is called hydrogen amine, NH2, NH2. These all are a nitrogen having, in this all examples, nitrogen having lone pair electron. This is hydrogen. And examples of water also, H2O. It will have two lone pairs. Alcohols, ROH, and ethers, ROR, etc. That means which are having complete octet electronic configuration and it has at least one lone pair. It has at least one lone pair. Such a type of compounds are called neutral nucleophile. Nucleophile means it should give the electrons. It should has more number of the electron species of more. Okay, I am going to remove this page. Shall I? The next one I am removing. Next in this continuous point only, organic compounds containing, in this one only, nucleophile, neutral nucleophile, organic compounds, organic compounds, organic compounds containing carbon, organic compounds containing carbon-carbon multiple bond, carbon-carbon multiple bond. That means double bond or triple bond. Behave as multiple bond behaves as, sorry, as behave as neutral nucleophile, neutral nucleophile. Here example for this one, alkenes, alkynes, benzene. Alkene is double bond. Alkenes, alkynes, benzene, etc. And next one, ambident nucleophile. Ambident, ambident nucleophile, ambident nucleophile. We completed about the charged nucleophile, neutral nucleophile. Now we are going to discuss about ambident nucleophile. Ambident nucleophile is nothing but species having two nucleophile centers. Species having two nucleophile centers. Two nucleophile centers. But one is capable of, but one is capable of donating lone pair. Capable of donating lone pair are known as ambident nucleophile. ambident nucleophile. Ambident nucleophile. Examples here for ambident nucleophile: C triple bond N cyanide. In C triple bond N, there the here the carbon will get the minus charge, negative, and here nitrogen, the lone pair present are nitrogen. One more example, HSO4 minus. HSO4 minus. This means it's having like this O minus, and here sulfur. It contains 1, 2, 3, 4, and here also oxygen 1, 2, 3, 4, and here OH. Ambident nucleophile ante simple. The species which are having two nucleophiles, but only one is capable for donating lone pairs. That means ఇక్కడ దీనికి టూ ఉన్నాయి. ఇక్కడ it may be carbon also it will act as a nucleophile, and then nitrogen also it will act as a nucleophile. But if it sometimes this carbon may give the electrons, sometimes nitrogen also may give the electrons. So ఇక్కడ కార్బన్ అంబిడెంట్ కార్బన్ ఎలక్ట్రాన్ డొనేట్ చేస్తుంది, నైట్రోజన్ కూడా చేస్తుంది. కాకపోతే సిచ్యుయేషన్ బట్టి కొన్ని సందర్భాల్లో కార్బన్ బాండ్ అవుతుంది, కొన్ని సిచ్యువేషన్స్ లో నైట్రోజన్ బాండ్ అవుతుంది. సో దేర్ పాసిబుల్ సచ్ టైప్ ఆఫ్ ఎలిమెంట్స్, సచ్ టైప్ ఆఫ్ కాంపౌండ్స్ ఆర్ కాల్డ్ ambident nucleophile. లైక్ HSO4 ఆల్సో. ఇక్కడ ఈ ఆక్సిజన్ బాండ్ అవ్వచ్చు, లేదు అంటే ఇక్కడ ఉన్న ఆక్సిజన్ కూడా బాండ్ అవ్వచ్చు. అండ్ వన్ మోర్ ఎగ్జాంపుల్ ఐఎమ్ గివింగ్. Example, enough, this one enough, సరిపోతుంది. And one more also write it, propene, CH2 single bond and CH2, this is minus. Ambident is nothing but two, it contains two nucleophiles. Two nucleophiles ఉంటాయి, కాకపోతే ఒకటి మాత్రమే బాండ్ లో ఇన్వాల్వ్ అవుతుంది. That is called ambident nucleophile. These are examples of ambident nucleophile. And we know already the electrophiles are, we have given the condition, the electrophiles are Lewis acids, and here nucleophiles are Lewis bases, which are donate the electrons. Nucleophiles are Lewis bases. Nucleophile attacks the substrate. Nucleophile attacks the substrate. Nucleophile attacks the substrate molecule at the site of lowest electron density. At the site of lowest electron density. Okay na? Nucleophile, electrophile attacks the highest electron density, and nucleophile attacks the substance lowest electron density. Okay. Now the one more is important one, ambiphile. Ambiphile is nothing but they behaves both electrophile and nucleophile. They behaves both electrophile and nucleophile. Electrophile and nucleophile. And hence have the dual nature. And hence have the dual nature. Dual nature is nothing but amphoteric. Amphoteric. Example here, water and alcohols. Sometimes they may act as a amphiphile also. That means here water I am writing here, oxygen, hydrogen, here also hydrogen. Okay. It contains here two lone pairs on oxygen. So now if it is oxygen bonded with the other substrate, so this will act as a nucleophile. Why? Because it can donate the electrons. From water molecules, so called hydrogen attack it can act as a electrophile. Why? Because the oxygen can get the electrons from hydrogen. Obviously, the hydrogen will get positive charge. So in water molecule, the oxygen is acting a nucleophile. If it oxygen bonded with, that will act as a nucleophile. And if it is hydrogen bonded with, that will act as an electrophile. So these both are present in one water molecule. That's why this is called amphiphile. అంటే electrophile nucleophiles రెండిట్లాగా యాక్ట్ చేస్తే amphiphile. Ambident nucleophile is nothing but, what is the difference between amphiphile and ambident? Ambident means the species having two nucleophiles. న్యూక్లియోసెంటర్స్ రెండు ఉంటాయి, కానీ ఒకటి మాత్రమే బాండ్ ఫార్మేషన్లో ఇన్వాల్వ్ అవుతుంది. ఫర్ ఎగ్జాంపుల్ హియర్ సైనైడ్, ఇట్ మే బి బాండెడ్ విత్ కార్బన్ ఆర్ ఇట్ మే బి బాండెడ్ విత్ నైట్రోజన్. ద టూ పాసిబిలిటీస్ ఆర్ దేర్. కార్బన్తో అయినా బాండ్ అవ్వచ్చు, నైట్రోజన్తో అయినా బాండ్ అవ్వచ్చు. Okay, now if it is carbon with bonded with carbon, that we can call as cyanides. Cyanide. అలా కాకుండా ఒకవేళ నైట్రోజన్ తో బాండ్ అయింది అనుకో, దే మే విల్ గెట్ టు ఎన్సి, దట్ ఈస్ కాల్డ్ ఐసోసైనైడ్. కాంపౌండ్ చేంజ్ అవుతుంది, ఐసోసైనైడ్. సో దేర్ ఈస్ ద పాసిబిలిటీ to bonded with carbon and nitrogen. Such a type of compounds are called ambident nucleophiles. Amma electrophile is nothing but less number of electrons. Nucleophile is nothing but more number of electrons. Electron deficiency of electrophiles. Okay, now excess electrons is nucleophiles. Is it clear? Electron rich species are nucleophiles, are electron donors. Electron acceptors or electron deficiency are called electrophiles. Okay. Now we are going to discuss about the types of organic reactions. Shall I remove the page? Is it clear, everyone? Okay, I am removing this page. Shall I? Amphiphile is nothing but simple. Amphiphile is nothing but in one compound, one will behave as a electrophile and other will behave as a nucleophile. In H2O, their oxygen is behaving as a nucleophile. Why? Because by donating its electrons. ఇక్కడ H ఏమవుతుంది, by losing of this it will get the H plus ion, so it will behave as a electrophile. That is called amphiphile. Next, keep the heading. From here we are entering the main reactions. Listen very careful and daily you have to practice so many times these all reactions. Now very important concept we are going to discuss. టైప్స్ ఆఫ్ రియాక్షన్స్. ఇక్కడ నుంచి కేర్ఫుల్ గా వినండి అమ్మా. టైప్స్ ఆఫ్ రియాక్షన్స్. Types of reactions. Mainly, reactions are mainly four types. Reactions are mainly four types. The first one is addition reactions. Addition reactions. And second one is substitution reactions. Substitution reactions. Addition reactions, substitution reactions, and third one, elimination reactions. Elimination reactions. Third one, elimination reactions. And the fourth one, isomerization reactions. Isomerization. Isomerization we can call as one more rearrangement. Rearrangement reactions. Isomerization or rearrangement reactions. Generally, we are going to discuss about the only four types: addition, substitution, elimination, isomerization or rearrangement. The first one, keep the heading addition reactions. The first one, addition is nothing but adding only. Addition reactions. In addition reactions, it is also three types. It is also how many types? Three. It is also three types. The first one is electrophilic addition reaction. Electrophilic addition reactions. Electrophilic addition reactions. And second one, free radical addition reactions. Free radical addition reactions. And third one, nucleophilic addition reactions. Third one, nucleophilic addition reactions. Nucleophilic addition reactions. The first one, keep the heading electrophilic addition reactions. The first one is electrophilic addition reaction. Electrophilic addition reactions. Electrophilic is nothing but electrophile, addition of electrophiles. Ante. Electrophilic addition reaction means addition of electrophiles. Generally, addition reaction takes place in alkenes and alkynes only. So, because of presence of, no, we can write directly, alkenes generally take part in addition reactions. Alkenes generally take part in addition reactions. addition reactions. Okay, copy this one. I will remove this page. From here we have ఇక్కడ నుంచి మనకు మెయిన్ ఆర్గానిక్ కెమిస్ట్రీ స్టార్ట్ అవుతుంది. అడిషన్ టైప్స్ ఆఫ్ రియాక్షన్స్, నెక్స్ట్ ప్రిపరేషన్స్, ప్రాపర్టీస్ కంప్లీట్గా ఇవే ఉంటాయి. ఐఎమ్ రిమూవింగ్ దిస్ వన్. Addition reactions continuously. Example here, for example, C double bond C, it's bonding with AB molecule. What are the possible products there? One will be positive and other will be negative. Their homolytic fission takes place between A and B. So there the possible products are, the double bond will go what are the possible products here? H, that means single bond, and here A and here B. How it will happens? Carbon bonded with carbon. First this electrophile AB, it can split as it bonded with A and B. Just assuming now the B is more electronegative than A, then what will happen? It can pull the electrons from A towards B. So the result of it, it will get positive, and that B will get negative. Okay, this positive charge is nothing but this is electrophile. This addition we are going to discuss now. We are discussing electrophile addition reaction only. This electrophile, where it can attack the electrophile and alkene. In this, the electromagnetic effect takes place either both side. I am taking this side. Then what will happen? C single bond. C here minus and here plus. Is it clear, everyone? Now, when it's bonded with A plus and B minus, first the electrophile will attack on, just explanation, Amma. Listen, I will give the notes now. First, this electrophile will attack on negative charge. That is called rate determined step. Formation of carbocation. అప్పుడు ఏమవుతుంది? Here as usually plus and a single bond. Sorry, here one more bond also there. Single bond, and here A.